Okay, let's do a quick reminder about how we do long division. And then I will teach you a method called synthetic division, which is a much faster way to yield the same result. So let's first do this with long division so we can appreciate uh, how that would be carried out. So this would be the setup for it. We'd write x minus 3 x minus 3, and we're dividing that into negative x cubed plus 4x squared. There's no x term, so I'm going to have to put a 0x in there, and then plus 9. Again, remember, we always have to have our divisor and dividend. We always have to have those in descending order, and if we're missing one, put in a 0 in the variable that should be there. Doesn't change the value of what that polynomial is worth. 0 times x is still just adding a 0. Okay, and then we start to go about our business, and we say, well, what do I have to multiply x by to get a negative x cubed? The answer would be a negative x squared. And I distribute that to the x minus 3, and I get negative x cubed. I get positive 3x squared. Now don't forget, now we subtract this entire line. Okay, so we might subtract it. And I said yesterday, lots of times what I do is make this a plus and then flip all these signs. And that's how I can keep track. So I'm just adding vertically at this point. Negative x cubed plus x cubed, those equal 0. And this next one's going to be a 4x squared, take away 3x squared, so it leaves me with 1x squared. And then I bring down the next term, which is just this 0x. Now the question becomes, what do I have to multiply x by to get an x squared? Well, that's easy. I need to multiply by an x. So I put an x there, and then I distribute it times the x minus 3, giving me an x squared minus 3x. Strike a line, parentheses, subtract. So that means flip all those signs. And so my x squared and negative x squared, they add up to 0. And 0 plus 3x is 3x. And then I bring down the positive 9. I repeat again. I go x times what gives me 3x? The answer is 3. So I put a plus 3 there. I distribute it to the x minus 3, which gives me 3x minus 9. Draw a line. I subtract, which means change it to a plus and flip all these signs. And 3x minus 3x is 0. And 9 plus 9 is 18. And that 18 would be my remainder. So this is going to have a remainder of 18. So there it is with long division. Let's do this now with what we call synthetic division. For synthetic division, it's a much quicker process. It's going to be unusual to you, okay? One of the things you want to make sure of when we use synthetic division, you want to make sure you are only dividing by a binomial. So in this case, x minus 3 is the only time this works. And even if it's a binomial, you want to make sure this coefficient out here is 1. There are ways to get around that if it is not a 1, but it does have to be a binomial. And when we set it up, synthetic division, it looks like this. You make a little rectangle like this, or just a little corner of a box. And inside this box, you put what would be the zero of your binomial. The zero means what value of x makes this zero. In other words, if I said x was 2, well, 2 minus 3 isn't 0. But if x was 3, 3 minus 3 is 0. Okay, so you want to put a 3 in this box. Okay, you can also just think of it as it's always the opposite sign of whatever that number is. If that was x minus 5, you'd put a 5 in this little box we made. If it was x plus 3, you'd put a negative 3 in that box. Next, what you want to do is what you're dividing into. You're going to make a listing of all his coefficients. The first number, the number in front of x cubed, is a negative 1 right here. So you're going to put a negative 1 right there. The next coefficient is a 4. There was no x term. Remember, we had to put a 0 in for the x term. So we're going to have to put a 0 in our synthetic division. And then we put our constant term, which is a 9. So there's the setup. Just like you have to have a strange setup for when we do long division, this is the strange setup you use for synthetic division. Now you're going to want to skip a line, give yourself a little space, and then draw a line. And this process goes pretty quick. That's why it's a nicer way to do it. Step number 1, all you do is bring down that first coefficient. Just bring that guy down. Draw him below the line. Then you're going to multiply the number in the box, in this case 3, so we're doing a multiplication there. 3 times negative 1 is negative 3, and you put that answer under the next coefficient. So negative 3 goes under here, and then you just have to add those two together. 4 minus 3, that's 1. Then we repeat. This time we take the 3 times that 1, which is 3. We take the result, put it underneath the 0, and now we add that column, 3. Then we do it again. This time we take the 3 times this 3. That's 9. We put it underneath the last term, and we add those. Okay, and so we get this negative 1, 1, 3, 18. Now essentially when we do long division, we started with an x cubed term, and we took out an x to the first. So the answer went down by 1 degree. It went to x to the second. So when we do this division, it does the same thing. I divide it into an x cubed, so it's going to decrease it, and it's going to become an x squared, duration, then a plus x term, then a plus 3, and the last thing will be your remainder. Negative x squared plus x plus 3, remainder 18. The exact same answer we got when we did that long division problem. Negative x squared plus x plus 3, remainder 18. And while this process seems like, oh my goodness, I got to learn something brand new, yeah, well, it's really, really worth learning because you have to do this quite frequently. So let me write down another one, and let's just do it with synthetic division if possible. Again, remember we have to meet that condition that we're dividing by a binomial. So I've got one here. Let's do this one. Okay, so we're taking this big polynomial, dividing it by x plus 1. Okay, so again, we make a box. and we just use the opposite sign of whatever's in here. This is a plus 1, so we're going to put -1 in the box. We write down our coefficients, making sure we have them all in order. So we have 3x to the cubed, then comes our -2, because that's our x squared, then a 2 for our x term, then a -5. Skip a line, draw a line. Step 1, hardest one to remember. Just bring down the first number, 3. We multiply, that's -3, and you put it under the next term. We add those together, that's -5. We multiply, -1 times -5 is +5, so we put that right underneath the 2. We add 7. We multiply, -1 times 7 is -7, and we add -12. The original polynomial was x cubed, so now we are reduced by 1 degree because we divided out x to the first. So instead of being x cubed, it is a 3x squared, and then a -5x, and then a +7, and our remainder is -12. Let's go ahead and look at another example. We can see we're dividing by a binomial here. It's got a 1 in front of the x, that's good. Alright, so we go, okay, what makes this 0? +2 would. So we put a 2 in the little box here. Write down the coefficients. We have 1x cubed, -3x squared, -7x's, then our constant. Skip a line, draw a line. Step 1, drop the 1. Multiply, which gives us a 2. Put the 2 underneath the 3. Then we add straight up and down, that's -1. Then we multiply. 2 times -1 is -2. It's -2, so he goes right there. We add, that's -9. 2 times -9 is -18. Add those up, -12. We were at x cubed, so now we're at 1x squared minus 1x minus 9 with a remainder of 12. And so we've just carried out that division. A little more formal in our answer. In general, we'd say this division is equal to x squared minus x minus 9 plus the remainder over the divisor x minus 2. So that would be a true equivalency statement. That division problem is exactly equal to that quotient. I'll show you one more example, but this time after I write it down, you should pause it, try it yourself, then see if you've done it correctly. So here's the problem. Pause the video, see if you can do it, and then continue on to see if you've done it correctly. So I can use it because it's a binomial. I put -3 in the box, the opposite side. Write down my coefficients. There's 2x cubes. Ooh, there's no x squared, so I got to put a 0 in for x squareds. There is -1x, and then there's a -7. I drop the 2. I do my multiplication, -6. I add. I do the multiplication. It's 18, which is 17. When I add them, -1 plus 18. I multiply, which is -51, I believe, and then I add them. That gives me -58. And so I started with 2x cubed, so now I'm at 2x squared minus 6x plus 17. My remainder is -58, but we'll just write that as a plus -58 over my divisor, x plus 3. And we have just completed a pretty tough division had we done it with long division. And that's it for synthetic division. Much quicker and more efficient than long division.